my name is Katie Crandall Vigil. I'm with the National Weather Service Operations Proving Ground in CIWRO. I also do work pretty closely with the National Weather Service Training Center, so that's okay that it was on the agenda. So what I'm going to be talking about is specifically satellite RGBs and people with color vision deficiency, forecasters with color vision deficiency, and how they interpret those RGBs. Okay, so what is color vision deficiency? A lot of times people kind of misthink of what color vision deficiency is. Some people think it's an absence of not being able to see any color. That's not really what it is. It's more an inability to see certain shades of colors. And color vision deficiency is on a spectrum. You could have a slight degree of color vision deficiency or a significant degree of color vision deficiency. It is an X chromosome disorder. I'll talk more about what that means. 1 in 12 men worldwide have color vision deficiency, and only 1 in 200 women have color vision deficiency. And that is due to it being an X-linked recessive disorder. So for women to have color vision deficiency, you would actually have to have a father that has color vision deficiency and a mother who is a carrier of color vision deficiency. Men will only need to have, usually passed down from the mother, and they would only get one X. So they would get the X chromosome from their mother, they'd have the Y from their father, thus they would have a higher chance of having that mutation on the X chromosome. For women, you would have to have a much both X chromosomes would have to have that, mutation. Okay, so there are various forms of color vision deficiency. There's deuteranopia and protanopia. Those are the red-green color vision deficiencies. Those are the most common color vision deficiencies. There's tritanopia, that's a blue-yellow. Much rarer, and then a chromatopsia, which is a complete lack of color vision, but both of those are fairly rare in the population. So usually when we are looking to augment things for color vision deficiency users, we're going to look at red-green for the deuterans and the protons. Okay. So how did all this get started? In 2017, we actually had an evaluation of the Operations Proving Ground where we brought forecasters in that had color vision deficiency. They were red-green color deficient forecasters. There was 3 of them. And we wanted them to take a look at different RGBs and talk about, you know, how they use them, how they interpret. Are there any RGBs that were difficult for them to use? So we brought them out for a week. We had a lot of different technology that we used to try to figure this out. So kind of first thing I'll talk about is the photograph that I'm in. There's actually 2 pieces of technology there. There's something called Enchroma glasses that I have right here. They're actually meant to help people with color vision deficiency be able to see more shades of color with more contrast. It's not going to fix color vision deficiency for a person, but it might help them see things a little bit brighter, make them be able to pick out colors a little bit easier. So we had them use these glasses. I brought them along. They're expensive. They're about $300 a pair, but if they are useful for someone, I definitely would recommend them. I'm also wearing eye trackers. It's kind of hard to see. That's something that we had forecasters put on, and they were able we could see where they were looking on the RGBs. How long they were sitting at a certain image, where their eye was going. These eye trackers are really neat because they are not software that was actually loaded on the computer. They basically had a cable connected to a laptop so you could see wherever they looked. It could be the RGB, another person, anything around the room. So we could spend time kind of seeing where they spent a lot of their vision. So that was kind of a neat piece of technology as well. Something else we used is an iOS and Android app. It's called Colorblind Pal. It's basically that image that's on the right. And the really cool thing about this is it basically helps people with color vision deficiency to be able to hold up the camera to an image, and it helps them interpret that image. They can do a lot of different things. They can bring out different colors. That image up there basically shows just focusing on the red and orange, and it grays everything else out. It also helps them kind of adjust for whatever color vision deficiency they have. The forecasters thought that was really neat. They actually, a bunch of them use them in their personal life as well, just to be able to help them kind of interpret what basically a specific color is supposed to be for a general population compared to what their vision is. So we had these forecasters out for a week. It was very interesting, and we did come away with some really good knowledge and some understanding of what RGBs would be difficult for them to interpret. The thing is, it wasn't a slam dunk. It wasn't something where, okay, they all agreed this RGB is difficult, and that's going to be difficult for every person with color vision deficiency because it is a scale. Because some people have significant color vision deficiency, some people have slight color vision deficiency. It's always going to be varying depending on the person. But overall, we found that the air mass RGB seemed to be one of the more difficult RGBs at the time in 2017 when we actually had the forecasters out. So if you look at the top is the deuteranopia viewpoint, and then the bottom is the protanopia viewpoint, the red-green. And you can see those two viewpoints are actually fairly similar. They're just a little bit of differences. But the big issue is that the stratospheric intrusion, the orange color, that's very hard to interpret and see in these two different viewpoints. It's hard for them to be able to see the difference, especially between the green and then the orange. So that was something they did mention, that the air mass RGB just was a little bit difficult for them to interpret just from a colors perspective. The forecasters do a lot of cursor overlays where they don't necessarily rely on the colors. They're also relying on the science, on what the different numbers are telling them, but they did basically tell us this is one that was a little bit difficult for them. So what did we do? This is a big thanks to Emily at NASA Sport that helped me to do this. We basically took the red gun and the blue gun and we swapped them. And this is the viewpoint that we have. So this is this new air mass RGB, and you see the main difference is that it's now shades of blue. Shades of blue is going to be a little bit easier for red-green color vision deficiency to be able to interpret, to be able to see. Interesting fact, that's why Facebook, and when it started off, is in shades of blue, because Mark Zuckerberg has color vision deficiency. So that's why he actually had it in shades of blue. So the deuteranopia and the protanopia viewpoint are much more similar. They're much more similar than the original new air mass RGB. So what we did is we actually created this RGB. We have the file. It can be ran in AWIPS. And then we had 22 forecasters with color vision deficiency look at this RGB. That was work on its own to be able to find those forecasters in the Weather Service. We estimate with just the number of people, there's about maybe 200 people in the Weather Service that could have color vision deficiency. Of course, it varies, who is willing to do this research, who's willing to talk about us with color vision deficiency, because there still is some stigma. Some people don't want their bosses knowing, some people don't want their coworkers knowing, because they feel like, they might get judged, that they're not as good at interpreting imagery, that there would have some sort of lack of ability, which is completely false. But some people still just didn't really want everyone to know that. So, but we did have 22 people that went through this RGB. 7 of the forecasters thought it was at least slightly more easier to interpret. 8 felt that it was moderately more easier to interpret, and 4 thought it was significantly easier for them to interpret. So as you see, it's a scale. Some people it's really going to help, some people not so much, but it's just the ability to have that in AWIPS that as a starting point is a great thing. And that's kind of what we want to start looking at is, can we maybe build a suite of RGBs that are specifically tailored to at least be a starting point for forecasters. It might not solve and might not be the best image for every single forecaster, but it can at least give them a starting point. So at least we're trying to get this new air mass RGB into AWIPS. Talking to Bill Line, what you've done, love to talk about the dust RGB, getting that in as well, and just basically having this available to forecasters. And then it can also be distributed to the public, and just talk about equality and equity and helping our users that might have color vision deficiency be able to see these imageries. So where do we go from here? Kind of the first thing that I did is created this National Service Color Vision Deficiency Working Group. There's about 10 forecasters that are willing to help the Weather Service, help CIWRO, help any entity with color vision or color tables or anything that has to do with color, and they're willing to take surveys, they're willing to look at this imagery. So we now have that available. We have these forecasters that want to help, that want to find solutions for other forecasters and be supportive. Reach out to other agencies. What are other people doing in the world to help with color vision deficiency, with different RGB satellites? Where can we go from here? Identify new RGBs that could use adjustments. We did this in 2017. A lot has changed now. We have different RGBs, different recipes. how can we figure out what other RGBs could use some tweaking to help forecasters. Something at the very end, and we can talk more about this in the next couple days, is training on the composite options tool and some of the things Bill Line works with. Forecasters are already doing this. They're already kind of tweaking RGBs, trying to make them more easy for them to view, but we don't want them destroying the integrity of the RGB. We want them to do it in a way that it doesn't compromise what the RGB is trying to show and not completely mess up the imagery. But they do this, and I think there needs to be decent training to help them be able to, adjust whatever they need to make it easier for them to interpret. And this goes for not even just forecasters that don't have color vision deficiency, because I think everyone can benefit from tweaking these RGBs a little bit, having colors stand out more, just being able to see things a little clearer. So that's something that I like to maybe talk with other people about in the future. So these are just some useful links that are kind of especially great if you want to do some color vision deficiency work. CoBlinder, it's a color blindness simulator. You can go on, you just Google it, go online, and basically any image that you have, you can upload it to it, and they're going to show you what it looks like for someone that has red-green colored vision deficiency, that has yellow-blue colored vision deficiency. So you can see what they're actually seeing. It's not as great as actually having a person with color vision deficiency looking at something, but at least it's a simulation that can help get you an idea. Just color blindness awareness gives you more information about color vision deficiency. That colorblind pal, that basically that iOS and Android app, it's free, which is amazing. They don't charge anything for it. It's been very useful. In Chroma, basically if you want to get these glasses, order these glasses, you can go to that site, and I have a pair here for anyone that wants to take a look at them. And then if you are interested in eye tracker technology, check out Pupil Labs. They created these eye trackers to try to help with research because they're a lot less expensive than other options for eye trackers. Usually eye trackers, when we looked at other groups besides Pupil Labs, they were in the $10,000 to $20,000 range for eye trackers. We bought 3 eye trackers for about $2,000 to $3,000. So it's a lot easier to afford. And I think there could be a lot done with RGBs by just using eye tracker technology. So, okay, thank you.
Thanks, Katie. Questions, comments?
Hey, Katie, great presentation. I thought I saw the agenda and I thought this was very useful we have some colorblind people at AWC, and they do some tweaking on ourselves, like in AWIPS, to actually kind of, make their own procedures and stuff like that based on their colorblindness. And I'm thinking, something like this to where we can kind of work together. I mean, we're right across from each other. So I think that doing this because I'm colorblind myself, so could have a very good beneficiary, factor for the AWC, especially, with dust. Dust is, for me, when I'm making procedures for forecasters to use, it's very hard for me to see. So, Bill was showing, or, everybody else was showing dust in yellow. That's very easy for me to see. So I'm thinking, testing with these colors and stuff like that could be very beneficial in the future. So
thanks, Katie. When we have new RGBs, we can essentially come up with numerous iterations of exactly the same information. It'll look completely different, but it's the same band, same ranges, same gamma. So would you concur that it's a best practice for us to evaluate all possible iterations of an RGB before adopting it in the future?
I think it'd be really useful to talk to forecasters that are, we have a large portion of, surprising large amount of forecasters that would be happy to look at these things. I think we need to spend time with the users that do have color vision deficiency and, just having a double check on some of these things and having them take a look. We have these people, it helps them to feel more involved, more part of this community, and they're there and they want to help. So it would be, I think, a great idea.
And then maybe just a quick second question. It seems a lot of it is the the red, green color deficiency. Should we just have an option in AWIPS to just exchange those two? I have no idea if this would actually work effectively to solve at least part of this problem. But should there be an option to just exchange those two bands instantly?
I think we need to do a little more research. I'm actually going to throw that to you, Bill. What do you think of the possibilities on that?
I couldn't say.
Yeah,
Okay.
I think we'd have to bring people out and actually test that and kind of see with other RGBs and see what that does and see how useful that would be. So,
Bernie, do we have anything online? Bodo, please.
Yeah, just very quickly there, Katie. I've just some statistics from my end. The research paper that I co-authored, we actually interviewed 115 bureau staff about, and we also had this idea, asked them about color, difficulties in perceiving color, and we came up with 3% that actually said that. And yet, when we conducted an Ishihara type test during our AMS-UC Asia Oceania Meteorological User Conference training event a couple of years ago, there was 10% that actually came out. So there's a big difference between people who would actually volunteer information and people who would realize it when they're actually looking at these test studies, or these Ishihara circles. So yeah, that was one point that I wanted to just mention. The second point, very quickly, from an educator's point of view, if you're trying to put an exam out where you're testing the student's ability of being able to pick up an RG, being able to detect signals in an RGB, in the past I've had to split that question into a verbal understanding of the procedure and then an option where they could look at an image. But what I've done more recently is actually highlighted certain areas so that everybody could have a go at identifying, say, fog in a night micro RGB. And students have come back and said, this is really, really useful. And but I think what you're doing extends it one step further. So really interested. Thank you.
thank you very much.
Bodo, while we have you, can you try turning on your webcam and see if it works?
Well, yeah. Try my webcam. Let's see. I've got my webcam on now. I'm happy to, if it's simpler and for the convenience of everybody just to be a voice, I've got my webcam on at the moment, but I don't know how to engage it using this webinar. I do have the webcam option, but yes, it's only showing Katie at the moment.
Yeah, I thought that I unlocked them, but I don't. Anyway, we'll work on that and we'll see if we can get it fixed before your presentation later.
All right, no worries. Thank you.
All right. Last call for questions for Katie or comments. All right, thanks, Katie.